I hope everyone's doing well. I'm Mr. Rich. Thank you for joining me for this video. It's an interesting question here, differential equation that we have to solve, but it's confusing for many students. It's a simple one, but again, it appears to be a source of confusion. So in this video, let's examine it. Why is this differential equation confusing for students? We have dy over dx is equal to 1 plus y over x. It can be done by two different routes, one of which is quick and easy, the other one is longer and it's harder. We will examine them both. Let's look at the longer and the harder route first. We will call that the substitution route. Now look, we have dy over dx is equal to 1 plus y over x. If you do a common denominator, what happens? You have dy over dx is equal to, you can do a common denominator, x plus y over x. Now what we will do over here is a substitution. Again, this is a longer, harder approach. The substitution route where y is equal to vx. It's a specific technique with regards to solving differential equations that's usually called the vx technique or the substitution technique. If y is equal to vx, then derivative is equal to dy over dx is equal to the derivative of this using the product rule. What will you have? You'll have v plus x dv over dx. Do implicit differentiation of this using the product rule. This is what you have. Now you have substitutions to make. The dy over dx is equal to all of that. I have dy over dx. I'll bring in all of that. V plus x dv over dx. I have videos on this in my channel in the playlist regarding the first order differential equations. Look right here and bring your substitution for y. I have x plus vx over x. What's the reason for this substitution? We're getting rid of the y. Isolate over here. I have v plus x dv over dx is equal to x 1 plus v over x. This cancels out. I have v plus x dv over dx is equal to 1 plus v. You take this v on the other side, it'll cancel out. What remains? I have here x dv over dx is equal to 1. Push the x on the other side. I have dv over dx is equal to 1 over x. Integrate with respect to dx. I'm integrating here with respect to dx. These will cancel out. Now I'm looking here at an integral dv. The antiderivative from that is v. The integral here 1 over x. The antiderivative is natural log x plus c. But v is equal to something. Look right over here. Solve for v. V is equal to y over x. Now bring that in. Y over x is equal to natural log x plus c. We have eliminated the v. The substitution has served its purpose. Now we're bringing back the y variable and solving for it. Y here is equal to, push the x on the other side, x natural log x plus cx. And here is the solution for the differential equation, which I'm posting for you right here. Y here is equal to x natural log x plus cx. In some areas you might put a 1 over here. It's fine. There's no need to, but that's your solution for this using the longer, harder route. Easier route. Recognize you have a first order differential equation, which we know, but it's linear. Push the y over x on the other side. Minus y over x is equal to 1. Linear. It's a linear differential equation. You are really looking at it in the following way. Let me rewrite it out for you so you see it. 1 over x, y. Now you can do the integration factor. Here is the coefficient of y. Your integration is integral this minus 1 over x dx. What are you going to get from here? The antiderivative of minus 1 over x is no different than you looking at integral of minus 1 over x dx, which you are looking here at e to the minus natural log x. That's what you have, and you know what this is equal to. It's equal to 1 over x by means of an identity. E to the exponent natural log x is equal to x, but e to the exponent minus natural log x, which is what you have, is always equal to 1 over x. These are logarithmic identities. Memorize them. I have 1 over x, which you will multiply with everything over here. Your integration factor is coming back as a product to everything. You'll have 1 over x dy over dx minus 1 over x squared y is equal to 1 over x. This right here is actually the shorter, easier procedure. Look right here, it's coming from the derivative or the implicit differentiation of something. What is that something? It's really y over x, or you can write it in a better way. The product rule, derivative of y times x to the minus 1. If you do the derivative of y x to the minus 1, this is exactly what you have. There's no confusion about it. Is equal to 1 over x. Do the integral. When you do the integral here, integral and derivative cancel each other out. You have y over x is equal to the antiderivative natural log x plus c. Solve for y. Push the x onto the other side and multiply with everything. X natural log x plus cx, and we are done. And you see it. The second approach, linear approach, using the integrating factor, is the better approach. The original approach, substitution, is the source of confusion for students and it's prone to errors. And that's it. Thank you for watching.